Okay, so in your notebook, just go right directly underneath wherever you picked up yesterday. And what question number was I on?
Number 5, so this is going to be 5.
Okay.
So number 5. So again, following through from yesterday, I want to give you another one of these all the way through here first before I show you Descartes. So number 5, I'm going to say that we need to find all the zeros, rational and the others, obviously. So find all of your zeros. So walk you through the whole process. In your function, I want to go f of x is equal to, and x to the 4th, and then plus 5x cubed, and minus 27x squared, plus 31x minus 10. Okay. What is the degree of this polynomial? Degree 4. So how many zeros are we going to obtain? 4. So this is n equal to 4. So we have 4 zeros or roots to find. I'm going to begin by labeling my P and Q and generating a list of possible rational roots. Again, these are just possibilities. Obviously, they don't all work. So this is your list of possible rational roots. We're going to go possible rational roots. Okay, so you are going to list out the factors of P divided by the factors of Q. Plus and minus at the front. Okay. So the P value is 10. So what are the factors of 10? Very good. 1, 2, 5, and 10. And then next, you're going to list out the factors of Q, which is just a 1. And then you're going to make your list here. So this is equal to, I have plus and minus, 1, 2, 5, and 10. Okay. So again, on the calculator, you're going to draw your eye to those 4 values, but also plus and minus, so 8 altogether. And we are going to look for where does this hit the x-axis. So again, that's your shortcut. So you're going to go right into the calculator, type this in. And we want to identify which of these are zeros. So in the calculator, I am going to go x to the 4th, and then plus 5x cubed, followed by negative 27x squared, and plus 31x, and minus 10. And I'm going to hit graph. And again, this is a degree 4, so you probably are going to be able to see 2 of these. All right, this first one right here, it looks to me like we are at 1. And then it also looks like we are at 2. So let's confirm that. All right, so are we at 1? Yes, and 2. So those are 2 rational roots. It doesn't matter, again, which one you do with synthetic first. I guess I'll just use the 1. And then we're going to divide the 2 through as well. So I'm going to go back. We have determined that 1 is a rational root and 2. So I'm going to get here 1 divides into. Do we need any placeholders? Nope. So 1, 5, negative 27, 31, and negative 10. Okay, so your first value comes straight down. Multiply, add, multiply, add, multiply, and then add, multiply again, and then add. Again, you know this is supposed to work, so we're good. Now you're going to do it again. So I am going to take my next 0, which we determined was at 2. And I am going to divide that through the answer I just obtained above. So 1, 6, negative 21, 10. So 1 comes straight down, 2, 8, 16, negative 5, and negative 10. Again, it works. So what remains here? So my polynomial, was it f of x or p of x? I can't remember in the top one. F of x, thank you. So f of x is equal to, right now we have the factors x minus 1, x minus 2, leaving us with a quadratic x squared plus 8x minus 5. So now you can work with this. Because again, this question started with a quartic function, which means if you only divide systematically once, you're left with a cubic, which you cannot use quadratic formula for. Now you have a quadratic, so you can use the formula. But you had to get down to this level. So now I go x is equal to negative 8 plus or minus the square root of 8 squared minus 4 times 1 times negative 5, all divided by 2. So x is equal to negative 8 plus and minus 64 plus 20 is 84 over 2. And then, of course, you're going to simplify the 84 in first base. X is equal to negative 8 plus and minus 84 is 4 and 21. So I have 2 radical 21 all over 2. And then you need to reduce those 3 values. So divide by 2, divide by 2, and then the bottom's going to drop off for you. Okay. So this particular question has 2 rational roots and 2 irrational roots, and all of them are real. So we have 4 real roots, 2 of which were rational and 2 of which were irrational. 2 irrational. And again, those irrationals are always going to come in the pairs as well. Okay. What were my answers? I'm looking for them here. So your zeros were at 1, 2, negative 4, plus and minus the square root of 21. Okay, how do we feel on those? Pretty good? Okay, so let's change gears to your sheet. And I'm aware that these are probably stapled out of order. Can you please locate the sheet that says functions practice A? It looks like this. Because A and B are almost identical. So we're going to do A first and B will become your homework. And we're going to just briefly talk about Descartes' rule of signs, which is just simply another tool to help you determine which of those possible rational roots are actually going to work in the instance that you lost your calculator and had to do the synthetic. Okay. So Descartes' rule of signs, I'll give you a little bit of looking for some space here. So Descartes this is a tool that looks at sign variation. So this is just another tool to help you that looks at sign variation to determine your rational roots. So it narrows things down for you a bit. So once you have the list, you can look at your sign variations, and then you would essentially maybe not have to do the synthetic 8 times. You could rule it down to like 4. So that's what this helps you to do. So I gave you a function. So you have 5x cubed minus 23x squared plus 17x minus 3. And we're going to look at the sign variations for the original and for the negation to determine what type of roots we're going to have. So here's what we do with Descartes. I'm going to look at this function here and using just the original first. This is going to tell me my possible real rational roots. So I am looking right now for real and positive. So I'm going to look at sign variation. So I'm just going to write this. And what we mean by sign variation is it goes from positive to negative or negative to positive. Okay, so here's my original. So I'm looking for how many sign variations do I have? So I went from a positive to a negative. So isn't this one? And then I went from a negative to a positive. Doesn't that vary? 2. And then positive to a negative. Isn't that a sign variation? 3. So we have 3 sign variations. And what that means is we may have 3 positive reals. Okay. So I go down to my chart and I can have 3 positive reals. Now this polynomial was a degree 3. So if we have 3 positive reals, how many of these are we going to have? None. How does that help you? When you make that list of possible rational roots, when I have to even consider the negatives, no, they're not going to work. So the next case you can have here is what you do with your positive real rational roots is you immediately subtract an even integer off of this. You're going to go minus 2. So that means that I could also have 1 positive real rational root. That is very wordy, I'm sorry. I could also have 1. Now we check the negative to figure out the rest of this chart. And you're not necessarily going to use all of these rows. So now I am going to plug in negative for all of the x's. And this is going to give me the reals that are negative. So I'm going to go 5 times negative x to the third, and then minus 23 times negative x to the second, and then plus 17 times negative x and minus 3. And then all we're going to look at is the sign variations here. So I would be left with negative 5x cubed. And then minus, that would be 23x squared, because that becomes positive, minus 17x and minus 3. All right, how many sign variations? None. 0 sign variations. So guess what? For negative, what do I put here? 0. So what that means has to happen here, if this is a degree 3 polynomial, then how many imaginaries am I going to have? 2. Okay. This is just a process to consolidate. If you had to do the synthetic division, which ones you would actually have to check. Okay. It's just a tool. So now let's go down. Let's make our list of possible rational roots from yesterday. And then we'll do a test here, but we're only going to test the ones that we've consolidated. So use rational root theorem to find all your possible rational roots. So everything that's possible here means p divided by q. So factors of p divided by factors of q. You're going to generate the list, and then we're going to cross off the ones we ruled out because of Descartes. Okay, so what was our p value from above? Negative, sorry, just 3, right? Yeah, so P was 3. So factors are going to be 1 and 3. And then our Q was 5. So 1 and 5. So here's our list. And I'm going to do this on purpose for a second. So I'm going to write out the positives and the negatives just so that we can cross them off using what we just did for Descartes. So I'm going to do 1 over 1, which is 1. And then I would also have negative 1. I would go 1 over 5. And then I would also go negative 1 over 5. Keep going. I would do 3 over 1 and negative 3 over 1. And then I would do 3 over 5 and negative 3 over 5. Okay. So again, if you did not have a graphing calculator to look at your graph and figure out which ones work, you would now look at Descartes and you would say, what can I eliminate? So with Descartes, we, I believe, got no negatives, correct? No negatives. So I would be able to take this list and I would say, don't have to check it, don't have to check it, don't have to check, and don't have to check. Because we had no negatives. And again, you're only going to know that if you apply that rule. So now what remains is, what do we have? 4 of these? Okay. So now you're going to check and see of these 4, which ones actually work. Should I make you do some synthetic? You could probably do this pretty quick. So we're going to test 1. You don't even have to finish the problem. If it doesn't work, you're done. So I'm going to use 5, negative 23, and then 17, and then negative 3. All right, fast. So 5, 5, negative 18, negative 18, negative 1. Does it work? Next, we're going to rule out 1/5 or rule it in. Well, someone's got a really lucky guess here. 1/5. So I have 5, negative 23, 17, negative 3. Come straight down, multiplies as 1, negative 22, negative 22/5. Is there any way this is working? No. Next one, 3. So I check 3. So 5, negative 23, 17, negative 3. So 5, 15, negative 8, negative 24, negative 7. Does that work? No. And then last, this one better work. 3/5. So I have 5, negative 23, 17, negative 3. 5 comes right down. And then multiply, I get 3, negative 20. Negative 60 divided by 5 is negative 12, which gives me 5. 5's cancel, gives me 3. It finally works. Okay. I mean, if you have 4 of them to do, obviously you definitely want to use a calculator because it takes a while. Now we're going to continue this. So here's my resulting quadratic. So now I'm going to take 5x squared minus 20x plus 5 equal to 0. Can't we divide everything by 5? So I have 5. I'm left with x squared minus 4x plus 1. And now it doesn't factor, so quadratic formula. So x is equal to 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 1. All over. And then we have here a 2. All right, so continuing. So I have x equal to 4 plus or minus I have the square root of 16, and then minus 4,
And then over?
and then 2. All right, so continuing, what do we get from this?
So x is equal to 4 plus or minus
Square root of,
over 2.
and then what can we do with the square root of 12? Yep, 2 radical 3. Yep. We have x is equal to, so I have 4 plus and minus. I have 2 radical 3 over 2. Other root would have been, looking for it, 3/5. Okay, so on your next one, let's just practice part of it. Okay. Yes. So reducing, sorry, running out of space here, divide by 2. Squeeze it in. And then 3/5. Thank you. Okay, so on your next one, let's practice another Descartes, because that is new to you. So we are going to look at sign variation. So it just means when you're going from positive to negative and vice versa. So first, let's do your positive. So using your original. So using your original. So I am going to go here and I'll do this right up at the top here. So this is positive reals. How many sign variations? 1, is it 3? 2, 3. Excellent. So 3 sign variations. So I'm going to go right down to my table and I know 3. What's the degree of this polynomial? Degree 4. Okay. So actually, you can fill in the rest of this row. If we get imaginary, don't they always come in pairs? So we can't have any, right? These have to be in pairs. What about negative real numbers? Could you have one of those? We're going to have to. Okay. Now, we always take that 3 and immediately subtract 2 from it. Like if you had 5, you would subtract 2 and then subtract 2 again. So now we have a possibility of just 1. So again, what do? You just subtract -2. That is the rule. Now let's look at your next case here. So we're going to plug in the negative x. So I'm going to now sub in the negative x. And that's going to give us our negative real. Okay. So now I would have here negative x to the 4th minus 8, and then negative x to the 3rd plus 24 times negative x squared minus 32 times negative x, and then minus 65. Okay, so I have x to the 4th. This is going to become negative, multiplied by a negative would go positive. And then another positive. And then another positive. And then we have minus 65. So how many sign variations here? So just one? Just one sign variation. So we have one sign variation. Okay, so that indicates that we have one negative real number here. I'm going to go 1. Okay, so 1 right there. Which means over here in my last column, I'm going for 2. So let's list out your possibilities here, and then I think I will have you just find, we'll just find the real ones here. All right, so use your rational root theorem to find all possible rational roots. All right, so we're gonna look. And we have here, your p-value was what this time? 65. All right, so factors of 65. We have 1. How else do you get 65? What are your factors here? 5, 13, 65. Good. So 5, 13, 65. And would you agree that 65 is not going to be visible on a graph? Yeah, so you might have to do synthetic with that. Then the Q value in this case was, Q was just 1. Okay, so here's your list. This is just your whole possible list. We won't rule anything out just yet. And then I'll let you use your calculator on this one just to speed it up. So this polynomial was a degree 4. So from your calculator, you should be able to find at least 2 of these. Did anyone find them yet? So type your function in your calculator and look at 1, -1, 5, -5. I found them already. -1 and what else worked? 5.
A lot of decimals and a 1. So do we just count it?
Yes. All right, so now we're going to start dividing this. So the -1 here. So I'm going to go, coefficients were 1, and then -8, and then 24, and then -32, and then -65. So for the sake of time, I'm going to change this question. Instead of all actual roots, let's just find your rational, and then you can stop. All right, so straight down, I'm going to go 1, and then multiply, and then add, and then multiply, and then add, and then multiply again, and then add straight down, and then one more time, 65, and we get 0. Okay, so you verified that it works. You definitely have to do that with the ones that do work. One more time. So I'm going to go 1, -9, 33, and -65. Again, you go right off your own work from above. So I get 1, 5, -4, -20, 13, and 65. So there's your remainder of nothing. And you have confirmed that you have more roots here at -1 and 5. So we're going to say that your real rational roots because I'll just make you do that part and you can stop just like on homework for the time being, were -1 and 5. Okay, and obviously you would have 2 more to find if you were asked. How are you feeling with that procedure so far? Pretty good? Okay. So I would like you to complete worksheet B, please. And then when you return on Monday, we'll do another problem or 2 together. We'll do some quiz review and you will take your quiz on Tuesday. No homework over break.